Alright, so we're going to give a quick rundown of the mechanical system in the house. For heating and cooling, we're supplying that to the house through radiant PEX tubing embedded in the concrete slab. And you can see those orange pipes in the back there. These right here are supply and return loops connected to a header. We reduced the cost on that end because we maintained even loop lengths throughout the whole system. Which doesn't require flow sensors to make sure that all of the different loops are flowing at the same speed. So by keeping those the same length, we've reduced the cost on the installation of the radiant system. So, but we're providing the heat to that through the use of a geothermal heat pump, and you can see it right here. This is a water furnace geothermal heat pump, and we have that set up so it's actually making 100-degree water, but it's up to 102 right now before it kicked down. So what that does is that takes heat, actually moves heat from these black insulated pipes here through this flow center right here. What we do is we have 1,800 feet of pipe buried in the ground outside as an exchange field. What that does is bring this water in at a consistent temperature and exchange the heat in the ground, and we extract that with the use of the heat pump. So even though the water coming out of that ground loop, it's an antifreeze solution, it's designed to go down to about 20 degrees. And the heat pump itself is putting the water back in the ground around 27 degrees, 28 degrees, and it's coming back out of the ground, 34, 35 degrees. So we're using that 35-degree water and actually making heat out of that. So this heat pump extracts the few degrees of temperature in the low compression side of the refrigerant cycle. And what it does, it takes that water, runs it through this pump here, comes up, there's a couple of pressure gauges and temperature gauges, that's all that's going on, and then it stores it in this tank right here. This is our hot water exchange tank. This is a TurboMax tank. It has a large exchange area, so we're only getting a 10-degree, we're getting about a 10-degree difference in exchange rate. So if we're putting 100-degree water out, we can extract on the radiant side out of that 90-degree water. We're actually mixing that down so we don't go over 80 through the floor. So this tank has 3 large coils inside of copper that exchanges the water into the radiant loop system. So from there, this radiant system comes up, and this is actually the return pump. So this water goes through the radiant floor. 2 zone valves have been installed in the back here. These are on the return side of the radiant loop, so we have 2 zones in the house. And then this pump will activate and circulate the water through the floor of the house. We have a mixing valve right here. Designed, we can put 80-degree, we can design that so we only put an 80-degree water in the floor. Temperature reading right here showing us what's going in the floor. And this temperature reading up here, which is showing us what's coming out back out of the floor after it's run through there. So that's the heating side, and you can see this zone valve right here is actually set up to control which direction the heat pump puts the energy. When we're called for heating, this pump activates and opens this zone valve right here, so that it opens up this tank so we can store the energy there. If we're calling for cooling, when this pump activates, it'll be put into this tank over here. It'll open this zone valve right here and dump the cold water into this storage tank. This is our cold water storage tank. And then when we're looking for cooling in the house, this pump will activate, and we're circulating the cool water through the floor for radiant cooling, which is something that isn't typically done. It does involve a little bit of consideration to humidity and dew point in the house. To resolve that, we put a whole house dehumidification system in here so we can control the humidity levels in the house. So we still have a little bit of work to do. There's a fill valve has to go in here. The wiring up here still has to be completed. It's a little bit tricky to get these controls just right, but the system is working pretty efficiently. Based on the engineering data provided by Water Furnace, we are running at about a coefficient of performance of about 4.525 right now. I want to show you dehumidification system up in the attic, placed in the attic, so we're drying the house out to make sure we have the right humidity levels right. Particularly important while cooling the house so we don't get condensation issues on the floor. Alright, so this is the dehumidification system. It's a whole house, a Honeywell whole house dehumidification system. It's designed to remove as much as 90 pints of water per day out of the house. Hooked up to a dehumidistat downstairs. So that when we're, especially when we're in cooling mode, we got to make sure we maintain our dew points a little bit above the water temperature coming through below the water temperature coming through the floor, so we don't get condensation issues in there. So this was a feature of the house that had to be added when doing the radiant cooling system in order to control that humidity, or else we'd have condensation building up on the floor when the dew point got too high. So we got a little P-trap in here. We actually suspended this from the rafters to stop vibrations. We insulated this up here just to keep energy contained. You can see a P-trap in the drain out here. And so far so good. We're moving a few 4 or 5 gallons of water a day. We've been working in the house, doing the floor, putting a lot of water down while we're washing those stained floors downstairs, and creating a lot of humidity in the house. Being so airtight, humidity can be a major problem in an airtight house, so this is an important feature, along with the heat recovery ventilation systems. Although those will bring fresh air in the house, they won't dehumidify the air. They will work as a dehumidifier when the humidity level outside is lower than the indoor, but if you have 100% humidity outside, you're actually going to be bringing moisture in, so this is an important element for heating and cooling this house and maintaining comfort level. Just to give you an idea of, this is the noise level. This is our heating system being activated, and that noise is only in this room. Because of the distribution through the floor, you don't hear any water flowing through the house whatsoever. If you can hear that, that is the heat pump running. You can see right now it's 84 degrees. That's going to continue to rise as it warms up that tank. Although we're extracting heat, we're circulating through the floor. This will only rise up to about 94 degrees while circulating that water continuously. Once the load has been met, the heat pump, the radiant system kicks off. This will rise up to 100 degrees and then shut itself down. And then what it'll do is every 5 minutes this pump circulates and tests the water in that system to make sure that it's maintaining a minimum of 80 degrees. Once it gets down to about 80 degrees, this heat pump will kick back on and heat that tank up to 100 degrees and make sure it's maintaining that. We have very, very little heat loss in that tank. This system was shut down last night. We had the heat set at 63 degrees, and with the solar energy coming off the windows, the house went up to about 67, 68 yesterday, and this heat never kicked on all night long, so we bumped it up another degree or two just to warm it back up because we had no sun today. It's going to be a little tricky with our solar windows and how to control this thing. So. Alright, so one of the other features you don't see here is we're going to be putting a couple solar panels on the roof of this house. We have another hot water tank for our domestic hot water being installed right here, and this wall is going to be covered with pumps and exchangers, because what we're going to do is we're going to take the heat off the solar array, and whenever we have heat being done, we're going to dump it into this tank through that valve right there. That's our where we're going to be running our solar hot water in there. So whenever the sun's shining, we're going to be maintaining this tank so that this heat pump never actually kicks on. So it's kind of a solar assisted heat pump system, and I'll show you a little bit more about that. That solar system is going to be tied not only into the solar to the storage tank for the heating. It's also going to be tied into the domestic hot water tank through 2 separate exchanges, so that once the demand is met for this the heating side of this thing, any excess energy generated from the solar panels will be dumped into the domestic hot water system. So it's just one more efficiency level that this heat pump may never kick on during certain times of the year, or very rarely. Maybe at the middle of the night when solar energy is not doing anything and that floor is regulating water. So